Okay, right, I think everything is running. Still waiting for a few people, and then we'll make a start. Hi Ross, hi Nick. Right, I just remember I haven't sent the link out. I'm just going to do this. "12 people there. Okay. Just going to send out the link just to make sure. Okay. Right, I think it's one or two missing. Right. Apologies for that. I completely forgot to send the email out. Right. I'm just gonna make sure everybody gets it. Right. That one has gone out. Okay. Right. Hopefully it's gonna go smoothly this time around, and we don't have to. I don't have to record. Let's see who we've got here. Okay, Ross, Nick, Callum, Charlie, Declan, Harry, Luke, Georgie, Hayden. Amy, Sam. Okay, hi. I think everybody's here now. We've got 14. Right, we're gonna make a start. This is the last session for the unit 309. Or not the last session, but the last presentation. The next presentation is just going to be about the assessment. I just have to. I think it's just a couple of things you have to write up, and then should all be done. You know, considering the whole Corona crisis, it should be done in a supervised environment. But considering what's happening at the moment, I think we can have a little bit of leeway here to get this unit through. Okay, I'm gonna check with Gary and just make sure everything is okay. Okay, let's make a start. So, energy in the food industry, and the unit is 309. The criteria 3.11, 3.12, 3.13, 3.14, and 3.15. And it's all about, you know, what's happening in industry, what's happening with energy. We've got sort of an old traditional approach where energy was not really a big issue. Nobody asked about energy as long as it worked and production took place. People just carried on, and whatever energy loss you had was just absorbed with the profits. But obviously, it's a bit different. Yeah. Hi, Alex. Good to see you on there. Right. Anyway, let's move through this. I have to make sure I get the right keyboard. Alright, that should be... No, it's not working. There we go. These are the different criteria which we're going to look at. Describe the energy audit process within a food and drink operation. Explain the sources of energy losses on a food and drink operations building. Describe the methods used to reduce energy losses. Describe methods used to monitor energy losses and consumption. Explain financial impact of inefficient systems. So most of it, I think, is almost common sense stuff. It's not really an awful lot to to cover or to dig into it, but we're gonna do a little bit, obviously. Just to anticipate a few things. So normally you look at whatever you do. It doesn't matter what system you have. You always look at the energy consumption, especially nowadays, and also the energy cost has risen quite significantly compared to 20, 30, 40, 50 years ago, where energy was relatively cheap. Oil was cheap, gas was cheap, coal was cheap in comparison to what it is today. And electricity with that was cheap as well, a lot cheaper than what it is today. And so, especially with modern technology, you can reduce the amount of energy you lose, and straight away this would translate into profit. And it's a box standard equation. You spend £100 on, for example, seals for your pneumatic valves, and you put them in as part of your normal plant preventative maintenance, your PPM routine, and suddenly you realize you don't lose as much energy, pneumatic energy, therefore the compressor doesn't need to work as hard, and you make savings straight away. And so after some time you now, okay, I save, maybe you spend a couple of £1,000 on these seals and the work you do, and you can almost calculate that after about a year you get money back out again, and then it's profit. So once you've broken even, it's just pure profit you get out of it. Sources of energy losses in food and drink operations building. Again, we've got wiring, we've got cable, there are losses in there. We've got heat losses if it needs to be heated up. We've got heat losses when I look at Hovis with your ovens as well. So in summertime, it could be a problem that if the oven is not properly insulated, the oven releases a lot of heat. And you may have air conditioning systems in some places to keep the working temperature adequate. And so you're sort of losing on one end and putting more energy in on the other side. And if you were to be able to contain the heat within the oven, you've got less losses in the oven, and you don't have to have a separate air conditioning unit, or it doesn't have to work as hard to keep the temperature to an adequate level. Methods to reduce energy losses. Again, a lot of it, we talked about it. Insulation of pipes, we looked at in other units. Insulation of buildings. Ensuring that pneumatic losses are kept to a minimum through getting good actuators, changing the seals on a regular basis, and maybe reducing transport routes as well within the system. So that could reduce energy loss. Describe methods used to monitor energy loss and consumption. Going to look at that as well. It's just meters, watt meters, and finally explain financial impact of inefficient systems. And it's obvious, it's almost self-explanatory. When you've got energy losses, energy comes at a cost. Very often the cost to reduce those losses is relatively low. So you could have a tiny investment, minimize losses, and maximize profit. So it's just a straightforward scenario. Okay, the energy audit. We've got a fancy diagram here, and we've got verifying and sustaining results. So where are we? Okay, so first of all, you conduct the audit, then you implement any changes. So you audit, what is your energy consumption, what are your projected losses, then you provide some changes, and then you verify and sustaining results. So you can then see whether it actually makes a difference, and then based on that you can carry on planning, and you can do this all as part of your PPM routine, plan, prevent, maintenance routine, and with that try and keep the energy consumption at a minimum. Results should be understand the energy being used, identify energy losses, do an analysis of losses, then obviously try to reduce those losses and recycle energy otherwise lost. And a good example is heat, which you could recycle quite easily. You capture the heat, you may have a heat exchanger. You might use it for heating parts of the building, especially in winter time, or you could use the heat for other bits. And it's happening. It's done all over. We've seen in power generation, when we've got coal-fired power plants, that heat is recycled. So the water that's been turned into steam is the heat from that is recycled and is used for other purposes. Your domestic boiler, if you've got a gas boiler, most of them are now condenser boilers. And what I find quite fascinating is that the gas which is burned off is actually cold when it comes out of the flue. Yeah. When you look at old boilers, the gas was quite warm and hot. Modern boilers, it isn't, and it's just like all the energy that's been generated in the burning process, up to about 90% has been used up to turn from burning gas into warm water, and it's, in a way, it's quite amazing, especially compared to older boilers. When you look at a gas boiler from 20, 30 years ago, and you look at a modern gas boiler, condenser boiler, they are much more efficient. Okay, just the same diagram which we had a look at before. I'm going to leave it up for a moment, and I can have a sip of tea. Okay, so we looked at this before. Okay, and we're going to move on. It's just another diagram which I picked up, and I thought might be quite interesting to stick it up here. So we've got energy saving opportunities and implementation. We've got monitoring and targeting. So the targeting would be, this is what we want to achieve. We want to have an energy reduction of a reduction in energy consumption of, let's say, 10%. How can we do this? What can we do to try and drive our energy usage down? So you do your audit, you look at compliance requirements, you have a meeting, you collect some data, you do site visits, you do an analysis and you report, and then you've got a final meeting and compliance, and then you go back into the circle. And so you're driving down the cost of energy. That in total the energy consumption is going down, and the profits are going up. The efficiency of the plant is going up. And it just takes like an objective look. Maybe an analyst, an outsider has to come in to just give it a good run over, try to understand the systems and see where potentially savings could be made, and do some projections of how much money a company would save. And I mean, for example, with Hovis, I mean, the ovens are massive you have. And I would think and I'm not sure how much heat is sort of escaping from those ovens when you work around them. But I would think if you improve on the insulation, it's just a one-off cost and a little bit of an installation. But if the plant is running like year in, year out, within probably about the first year, you would start noticing or making a profit based on the amount of energy you use. So the less energy is required because of the higher level of insulation, and the profit might kick in very soon. Insulation normally is not that expensive. Right, we've got Brett and Ryan as well. Hi there, good to see you on. Okay, we've got a case study here. What I want you to do is, the presentation is not that long, it's probably about half an hour. Pick up on these case studies and again, just a bullet point write-up, just a few sentences, and then upload it to one file. That's sort of the instruction I got from Gary. Everything needs to go up to one file. Also, please email me. I've received quite a number of emails. I'll reply to them later this afternoon. And thank you very much for sending in your work to me already. But also, please upload it to one file. Please feel free to, as evidence as well, the email I return to you to, copy it and stick it onto one file as well. Put it in a text document or under the text document of your work. just upload it as well, and that's all part of the process. Okay, the case study. A sewage plant needs to heat up sludge to create an ideal environment for bacteria to digest biological materials. Yeah. So we talked about this earlier, or I talked about this earlier. As part of the digestion, bacteria will produce methane. In early days, the tanks holding the sludge were heated up separately, and the methane was accumulated and burned off whenever a certain concentration was reached. To increase the efficiency, the methane is now captured and used to heat up water, which in turn is used to heat the plant and the tanks. Okay, so that's I mentioned this earlier in the previous presentation, and that's just a way how it can be done. Again, it's nothing for you to do with this case study. It's just an example, but there's just an easy way. So straight away, the cost for gas to heat up the tanks is gone down, possibly gone down to nothing. And in addition, you use the gas to you burn it off and you do something with it, so it's not wasted energy. I mentioned earlier Yorkshire Brick here in Barnsley, old company that doesn't exist anymore, but they did the same thing. They picked up the rubbish, put it back into the landscape where they've previously taken clay out. And they put some drainages in there, and they absorbed the gas, the methane that was developed through the rotting, the anaerobic rotting of biological material, which was sort of buried into the mound. And they were using this to fire the kilns, to burn the clay to create bricks. And again, massive saving, couple of 100,000, like £500,000 a year saving. So that's one way how you can make this sort of thing work for you and to increase energy efficiency. Okay, this is the next case study, and this is real stuff, and I was reading up on it some time ago. And it's just an assumption that 70% of pneumatic actuators leak air. So if an actuator leaks air, you lose power, you lose energy, and it says here that a plant in shutdown mode, yet with compressors going, the resulting noise level can give an indication about the leakage in the plant. And what this means is here, if the plant is not running, it's not operating, and for whatever reason, maybe it's a scheduled shutdown, but the compressor is still running, you hear all the leaking. And okay, I'm just getting a message here. I'm going to get back to you in a moment, Hayden. So that's a problem with with plants nowadays. We've got a lot of pneumatic actuators. So you can make an estimate to try and work out how much energy is lost due to leaky actuators, and then all you need to do is replace old actuators and replace the seals, which will reduce the energy loss. An analyst would have to determine the financial, health and regulatory impact of the leaks and recommend changes to be implemented. So I mean, this is real stuff and this is real life, and it's probably something you can relate to when you go to your plant and when there's a shutdown or a machine is not running, but the compressor is still powered up, and you can hear the hissing from all the pneumatic actuators, which are leaking air. Again, it's not a great cost. It's obviously the labor involved is substantial, but the seals which need replacing are just a penny a piece, just cheap articles, so they're not that expensive. Okay, Hayden, would this be the same as companies who make bleach selling the CO2 that is made as a byproduct? Yeah, pretty much the same thing, but it also feeds in when we look at waste products before in the previous lecture. Yeah, so it's an energy saving, and it's also a saving of the products which are produced as a byproduct. One example is one of the power plants here in the north. Drugs, they're called drugs, and they're near Goole, sort of on the way to the coast from Huddersfield, sort of halfway on the way to the coast. That's where they are. And anyway, drugs, they get the acidity out of the coal. They capture it with a filtering process, and they're using lime in the process. And if I remember right, the lime reacts with the acid, and it turns into gypsum, like the stuff you use for producing plasterboards. And so the byproduct is a building material, which they then in turn can sell to companies, to building companies, as a raw material. So it's interesting. So there are ways of making sort of environmentalism. It's not necessarily just a cost, which makes a product more expensive, but you can make it work for yourself, and make some money out of it. Right, move on. It's just a slide I found. So you do an energy analysis, you've got a walkthrough like an audit, and then you've got an energy survey and analysis, and then you would have a detailed survey and analysis, and then come up with some results. If we were at the plant in Huddersfield at the PMC, I would actually want you to do an energy audit, to just go through the plant and see what you could do to potentially reduce energy loss in the plant. And just an idea. Okay, next one. Where's energy getting lost within the food industry? And these are just a couple of ideas, and it's not comprehensive. I'm sure there's a lot more which you could add to the list. The first one is heat production. So heat is very expensive to produce, and like in ovens and so on, and again, very easy to sort of increase the efficiency through using insulation and minimizing any losses. The next one is transport routes. Sometimes plants, they are spread apart. So you might have a plant in the north of the country, another plant in the south of the country, and bits which are produced from both plants have to be transported one to the other. So again, there's maybe possibly a way to change the production process to make life a lot easier, to make sure that less energy is required for the product to be produced from raw materials to consumer ready. Motors, what type of motors are you using? Are you using single-phase motors, three-phase motors? Something can be done as well. So if you go to three-phase, they're far more efficient. How well are the motors engineered? Are they well oiled and greased? This is all little things which might make a difference and will not cost an awful lot to try and implement. Insulation as well, we talked about this. Duplication of processes. This is just looking at the production process as a whole. And could it be simplified? And that's normally what a systems analyst would do. A systems analyst would come into a company and just look at all the processes that are taking place, from beginning to the end of the product. And then typically he would look at where is there any duplication in the process. And maybe the process can be simplified. For the H&C class at the moment, I'm doing something which is called design engineering. And we had to go through some really interesting experiments. And one of them was building parts for, I think it was for a telescopic array for a tank. That's all it was, like a military tank. And it's just a case study. It was quite interesting to look at that. And there were, at the moment, about 14 different items to put this telescopic structure, to put it together. They had sort of a redesign, and they cut it down to about 3 parts. So all they had to do is just produce 3 parts for this part the company was manufacturing. And that was just simplifying the whole process. But the part had the same stability, the same functionality as the previous assembly. And I mean, stuff like that could potentially be an energy saving where processes are simplified and yet still work, and the same quality, the same robustness and everything else is still in there. Okay, the other one is as well something like pipe diameters. So if you've got like narrow pipes, you could lose a lot of energy in moving liquids from A to B, or semi-solids, or whatever is moved with the pipe. So little things like that could actually improve the production process and be more efficient. And again, the cost might be negligible, and it might actually be worthwhile to invest into a bigger pipe diameter, pay up for the engineering, but over the running of the plant or running of the machine for the next 10 years, you might get the cost out and save much more money. And then, for example, refrigeration is another area. If you use refrigeration, are there any losses? Are there any leakages where cold air leaks out and hot air gets in? Simple stuff. For example, if you've got a cold room and the doors open or can be left open, stuff where you have like little alarms or automated systems to automatically shut the door so that nobody can leave it open. Or you've got like a double door system where only one door can be opened at any one time, so you don't get all the hot air rushing into the cold room. Other than that, it might be a hygiene requirement as well to guarantee the temperatures are kept below a certain point. So again, there's lots of area and lots of scope to look at energy efficiency. Okay, Nick says, use a VFD on a motor for more efficiency. Good point. And again, they are not that expensive. They are not a couple of £100 for a VFD. You can increase the efficiency using a VFD. It's a good point. Thanks, Nick. Okay, we've got some factoids here. 70% of electricity produced is used for electric motors. That's just an assumption. I read this some time ago when I was looking at three-phase motors. And somebody came up, how precise those figures are is another story, but they reckon about 2/3 of all the electricity which is produced is used for electric motors in factories. And this includes your domestic usage as well. So I thought it's quite interesting. Another factoid is that combustion engines are only 20% efficient. So that means that the majority of your fuel is just sort of burned up and the energy is not really utilized. So the efficiency of combustion engines, like of your cars and stuff, is around about 20%. We've got some figures below here as well. So when you look at a modern condensing boiler, the efficiency is about 89 to 92%. A non-condensing boiler, 70 to 78%. An old buck boiler is about 60%. And a heavyweight old buck boiler is about 50%. Yeah. So you can see how over time the efficiency has gone up, and you can see also how much it costs. So when you have like an old buck boiler, the average cost for a semi-detached house for gas a year is about £1,200. If you use a modern condensing boiler, it's about £740. Yeah. Modern condensing boiler is about £1,000. So when you look at these figures, you know that within 2 years you have paid for the boiler. The boiler lasts about 10 years these days. So you've got about 8 years where you can start making some savings and save some money. And so there's a commercial point where efficiency, energy efficiency can materialize in pounds and pennies quite easily, and it doesn't take too long for it to happen. Right. Next point from Hayden. Heat from the combustion engine is used for heating the cars. Yes, it is. But and that's a good thing as well. So you don't have to have a separate heater. But you can just use the heat. I'm just trying to think. When you use air conditioning, what do they use with air conditioning? Are they using the engine heat for air conditioning to I'm not sure. I have to find it out. I never really worked on that, but if you've got aircon in the car, I know when you turn on your aircon, you lose you lose a little bit of performance in your car. When you turn it off, performance goes back up again. So there's a bit of a payback. Okay. A task. Within PMC plant, I make an analysis of potential energy loss accrued within the plant. So that's what I would have done with you originally. What I would like you to do is it can be fictitious, it can be real. Think about your place of work, or maybe your home, and look around and do an analysis. Yeah? And again, I'm not expecting you to have like a massive dissertation or anything like that. Just maybe half an A4 page, just a few bullet points. But I want you to have a look around, maybe your home where you are at the moment, or think about your place of work. If your memory is good enough and you can think about the PMC, have a mental walk through the PMC and have a look around in your mind, and make some suggestions of where could you save energy. Yeah. So for example, I'm sitting at home now, and when I do an analysis at home, just to give you an idea to set you off a little bit, I know my boiler is quite old. Yeah? So I could replace a boiler, and straight away I could go from, it's not a condensing boiler, it's an old boiler with a separate water tank, which is heated up once a day, and I've got warm water. If I change the system, I could make savings straight away. But cost me about £1,000. I need to find the money first. But eventually, after about 2 years, I would have the money back in savings. And when I look at my gas bill, it's quite high. What else? I've got a couple of windows which are quite drafty. They are double glazed windows, but you can open them all the way up. And probably all I needed to do is change the seals in the windows. Yeah? Again, a job maybe next winter or sometime I'll do so. And then when I look at the loft in the house where I'm at the moment, there's very little loft insulation in there. There's a little, but not much. But again, an easy thing would be is just to buy some loft insulation and put it in there. It would probably cost me about £100. But I would probably save money pretty fast, and I would get the money out within about 2 or 3 years for no problems, possibly even 1 year, with the lower gas bills I would have to deal with. I'm just trying to think. I think the doors are okay. A couple of things I could do. I've got a few outer walls. I could increase a layer of insulation. When we look at thermodynamics, there are a couple of things you can do, which are not very expensive. You could just, where the outer walls are, you could just put a couple of layers of insulation in there, and then wallpaper plaster over it. And again, the energy saving would be very quick. It would come very, very quickly. This is just a couple of ideas. That's what I would like you to do for the task. Maybe think about your place of work. Use a PMC if you want to. So that would do the trick. PMC, just to set you off a little bit. Some of the pipe diameters are really, really narrow. I don't know whether you've noticed this, which go from one tank to the other. And it takes actually quite a long time if you start pumping liquids from tank to tank, because of the diameter of the pipes. So an easy thing would be is just get Joe to put some, our Joe that is, to put some bigger pipes in. Probably, we don't use it all the time, but if it were a working environment, that would make life a lot easier. First of all, production would speed up, and secondly, it would require less energy to move liquids from one tank to another tank. There's a lot of space, or a lot of scope there for sealing off the factory. I think there could be some insulation below the ceiling to try and keep warm air in, so if people had to work there in winter time, would require less heating. And just trying to think, the windows seem to be okay, they're double glazed. Yeah, maybe a bit more insulation around the pipes, but it depends what will be manufactured there. Right, let's have a look. We've got a couple of questions here. Silicon will do. Yeah, will do big. That's true for sealing. Next winter, I'll give it a go. Okay. How much do devices in standby use? Is it better to have these offer energy efficiency? The answer yes and no. Yeah? Obviously, if you turn off a system, it might take some time to put it back on again. So if you, for example, a pneumatic system, if you turn the compressor off, the noise from the pneumatic actuators would stop eventually after the pressure has gone down, but to repressurize it might take some time. And if you wanted to be able to get the plant going within minutes, it could potentially be a problem, because you would probably need more than a minute or so to build up the pressure again for the systems. But yeah, that might be an idea, when you turn the plant off at night, because there's no shift, to turn the compressor off as well. Very simple way of energy saving. And one idea might be to maybe put a timer on, or very simple steps, but it would probably make a huge difference. Okay, the analysis. We look at typical production process of mixing a drink, follow the hypothetical process with view to determine energy consumption, suggest where excess energy may be used. Are there any ways to recycle energy? What areas would you look at to determine energy waste? That might be an example of typical analysis. I'm going to move on. The next question is, how do we monitor energy consumption? And the easiest way is obviously you get a meter, an electricity meter. I've got a couple of pictures here. I'm just going to, hopefully you can see the mouse. This is a typical meter. It tells you how many kilowatt hours are used. So it tells you how much is used at the moment, how much has been used over a period of time. There are similar meters here. Over here we've got a current meter. They're just a clamp meter. So you can, that thing, you press this red thing here, it's like a clamp which opens up. You put it on your wire, which you try to test, and you get a reading in how many amps are going through. Obviously, the voltage is 415 volts. You can then calculate the power that's used at this moment in time, and based on that, you might be able to run some calculations. Then obviously we've got the electricity meter, the gas meter, we've got power meters. There's something like airflow meters. And the latest generation of meters I'm sure you've heard of, are so-called smart meters. So the whole idea is there's some wireless connectivity to them. So the smart meter can tell you what has been used today and yesterday and so on. You can the meter guy can access it remotely. So there isn't the need for somebody to knock on your door and to take a reading of your meter. There's a little bit of controversy about these meters as well, because people can pretty much measure at any time of what's going on in your home, and it's a little bit like Big Brother's watching you. That's the Sam, are you here? Are you listening, Sam? Conspiracy theories coming up here. Smart meters, you become what's the term? Like very transparent. You become very transparent, and people can see what you are doing, when you're boiling your kettle and things like that. So it's not necessarily something you want. I don't know. Maybe you don't care. Maybe the benefits outweigh the potential of you being monitored in your everyday life. Okay, let's move on. What is the financial impact of energy loss? We've got a case study here, and it's in the 1980s. A forge used a lot of energy to produce its product. The annual bill of the forge was, again, £400,000 for gas. which would be about £2 million today. The forge had about 40 employees, 30 of which were working on steel forging. Heating for the plant and offices costs about 20,000 pounds per year. A lot of the flames are kept burning throughout the shift, even when forging is not happening. An analyst determined that this was happening for 20% of the work time. Some steel is allowed to cool down before the next production step and has to be heated up again. It is estimated that this is happening to half of the items produced in the forge. How much energy could be saved through the changes and the process of the plant? Try and estimate. Yeah. Okay, so when you look at this scenario here, it is just a matter of looking at the heat that is produced, and possibly siphoning off some of the heat for forging steel to heat the offices which are connected to the plant, and maybe the plant itself, if it is necessary. And then also, if you do some changes in the production process where steel is not allowed to cool down before the next production process or the next production step takes place, you could then again save a lot of money. So potentially, when you add all those figures together, you might be looking at about 60, 70, 80,000 pounds you could save, and that's a lot of money. Yeah. And at the moment, you're not getting anything for the way the plant is running now. It is just money thrown out into the streets. Yeah. Okay, that's it. Next one. I've got a video. I'm not going to run it now. It's about 14 minutes. That's about building a solar system. And you've seen this probably when you were at the PMC. When you look at Cummins across the road, they've got lots of solar panels on the roof, and there's like a little display, and they say that they saved so many kilowatt hours electricity today because they were producing their own electricity. I've seen this before as well in other companies where it's been done on a really big scale, where they had a lot of flat roofs, and all the flat roofs were kitted out with solar panels, and a huge chunk of the electricity the company was using was actually generated by them themselves. Solar panels have got a life expectancy of about 10 to 20 years, and then the performance is supposed to go down due to some of the semiconductor junctions breaking down due to the bit of UV light which comes through, and at the moment it's about £1 per watt. I think it's gone down a bit further, and they reckon that it takes about 4 or 5 years for a solar panel installation for the money to come through. So that means you've got about 10 years, possibly 15 years to make some profit, to get energy for free. What's happened now as well is the solar panels which have been installed about 20 years ago, they are now sort of coming into maturity. And when they are testing them, they're still about 80 to 90% of performance. Yeah. So they still work, and that means they might potentially still last another 10 years, and you still get some energy out of them, even not at 100%, possibly only at 90% or 85%, but still it's better than nothing. Yeah. So the lifespan of solar panels potentially might be about, and we'll be down now yet, but might be about maybe 30, maybe 40 years. So especially at your stage in life, if you buy a house and you install some solar panels on your house now, it will probably take you about 5 years to start getting some money back. But then you would still potentially have another 25 years if you stay in the house, where you get cheap electricity or free electricity, depending on how much you're using. Okay, research task, and this is for you to do. Kilowatt hour costs about 12 pence in today's market. Assume a small company uses about how many? 10,000? Is it 10,000? 10,000 kilowatt hours per year. The cost of a solar panel is about £1 per watt. 100 watt solar panel takes up about 1 square meter. The company has a flat roof of 10 times 5 meters. Reliable energy from the solar panels is at about 25% of given capacity in the UK. So in other words, if you get a solar panel that gives you 100 watts, you get reliably during a day, in average, about 25 watts out of it. Because, you know, the way the sun is. Today it's a sunny day here, so you would probably get about 80 watts or something out of it. But most days it's a lot less than that. The cost for charging regulators, inverters and batteries are about 1.5k. Expected lifespan of a solar panel is about 20 years with up to 90% of its initial performance. Do an analysis whether a solar panel system would pay for the company. How many years would it take for the company to get a return of their investment? Let's see what you come up with. You've got all the data. Give it a go, see what, do a bit of number crunching and a little bit of guesstimation, and how many years would it take for them to get their money back? Is it 5 years? Is it longer? Is it less? And how much money would they potentially get out of their investment over the lifespan of the solar panels? Okay, little job for you to do. And that's the last slide. Right. Hi, Sam. Any questions before I finish? We are at about 15 minutes, so we are just in time. Okay, your tasks, when I go through the presentation here, will be number one is the solar panel research. So that's one thing. What else? Let me just go back through the presentation here. Okay, right. Case study of the forge. So that's a case study here. Let's go back. Okay, and then what else have you got to do? You've got or the PMC, or okay, look at your place of work or PMC or your home and do an analysis about your current energy consumptions and savings. What I'm, again, just bullet points, don't go crazy. I just want you to think about potential energy savings to increase efficiency. And maybe, I mean, if you, for example, I gave you an example with my home here when I'm just looking around. Obviously, all I can do is just guesstimate. I can't calculate how much money I'll actually be saving. It would either be a very nice surprise or a very nasty surprise that I've spent a lot of money with little gain if I put loft insulation in and seal the windows and doors and put some insulation on the walls and things like that. But again, what I want you to do is think about either your home, the PMC, your place of work, and tell me what you have, where you think energy losses might occur unnecessarily, and what can be done to try and reduce those energy losses and guesstimate how much savings it might be, 5%, 10%. It's not an exact science, but it's just what I want to see is that you think about energy efficiency and energy savings. Right. I've got about 10 minutes to go. Any questions? Just going to go through the presentation just one more time. Maybe I haven't forgotten anything. We've got a task. We've got the factors. Yeah, that's okay. That's all. That's all. Just have a look at that. Okay. Right, I'm just here. Unfortunately, this is an awkward delay, which is about a minute. So when you hear me, I was probably talking about a minute ago. Okay, just waiting for questions come through. Right, we're going to carry on with this on Monday. On Monday, I'll just go through the write-ups you will have to produce, and so I do this in the morning. I just have a session with you. I'll try and clear with Gary what we can do and what we can't do. What else? That's on Monday. On tomorrow, it's supposed to be 308. If you've done your 308, everything is great. If you haven't done it, I'll be here, so you can email me if you need me to do a live session, to go through some stuff. I can do that as well. It's up to you. So I'm here I'm here for you. So my time is yours to use. I'll be available at 9 o'clock on the dot. And it's up to you. So again, I'm gonna do the same thing. So if some of you come to me and you say, "Oh, can you explain this? Can you explain that?" I'm not quite sure about this with my 308. I'll just send a quick email around, and then I'll give you about half an hour to stop whatever you're doing and be available if you're interested to come online and to join the discussion for tomorrow. If not, it's fine as well. Maybe we don't need one either. On Monday, I think it's about the same time. So normally I'm here in my little office at about 9 o'clock, and I set up the live session. So I just have to make sure the software works, and I give it a little bit of a test, and so that takes me a little bit of time, and I'm just going to look through emails and see whether anything is up. And then at 10:30 I would then do the presentation, just go through the stuff we have to do, and then we take it from there. So maybe in the afternoon we can make a start on 315, or if you need a little bit more time on 309, or there's some areas which you're not quite clear about, or you need a bit more help with the write-ups, or you need time for the write-ups, we are a bit flexible, so I can do this. Saying that, it's not on Monday, isn't it? Let me just check this. I think I'm making a big mistake here, because you've got Gary on Monday, haven't you? Let me just check. Just one moment on it. Gary sent me a timetable, and just one moment. I'm just looking at the okay, right. I'm just looking at the timetable to see what is the plan for tomorrow. For Monday, I mean, for tomorrow. Okay, we've got Monday. No, on Monday you're with me in the afternoon. So that's 2 o'clock. Yeah. So we'll whatever I told you, we'll do it at let me look. Is this right? 21st, 15th of April. Yeah. We'll do this at. Just looking at bank holiday. Yeah. Okay, that's right. We'll do this at 2 o'clock. Yeah. So it's just going through the assignment stuff and everything. In the morning, you've got Unit 307, which is with Gary. Yeah. And that's what I've got on my timetable here. Right, let's have a look. You've written something. I've sent a few emails regarding Unit 308. Wasn't quite sure. Yeah, Brett, I've received them. Sorry, I meant to answer them. I haven't done it yet. I'll get through it this afternoon. I'll sort it out. Yeah. So you'll get some responses in a minute. Okay, at this point, I'll end the stream. Just let me type this. Okay, I'm just keeping it open for a bit more, and then I'll go. Right, last bit. Please don't forget to upload the stuff on one file. Like all the exercises we have done here for 309, just whatever you do, upload them. I got your work as well, which you have sent through to me, and thank you very much for that. I really appreciate. I'll get back to you via email, and if you want to, you can upload the email and everything as well, so there's some trace of that has gone through the process. All it is just evidence generation for the IV and the EV. That's all. And I'm not sure, I think there are a lot more people looking at one file as well, and they need to see that we are active, that we are doing something during Corona season. Okay, I'll see you tomorrow morning, possibly. Yeah, so I'll be here. So if you've got any questions or you need me to do a session, as I mentioned before, I will do a live session, and then I'll email you prior to that. If it's not necessary and you're okay with 308, that's fine as well. I'll be available for you tomorrow morning. That's what I'm here for. Then next time I'll see you is not Monday morning, but Monday afternoon. Monday afternoon about 2 o'clock. And then we'll just go through the assessment for this unit. And then that would be Tuesday. I'm going to do HNC stuff. And then the following Wednesday, I'll be with you again. And we'll then probably make a start on 315. So that's what's happening on Wednesday. And then work our way through that, whatever is left. Okay. Right. I shall end the stream. Right. Okay. I'll end the stream at this point.